Okay, today I'm going to demonstrate writing a machine language subroutine for BASIC using Editor Assembler. Here's the basic version. What we're going to do is we are going to read the ROM locations and display it to the screen. So we're reading each location in the ROM and outputting whatever character it finds onto the screen. And in the upper right you can see the ROM location. So we started reading at 8000 hex. You can see we're in the extended BASIC. Now this is slow. So we're going to show how this can be done in machine language. So here's the same program in machine language. So we'll run 100. So now if you ever want to call this subroutine from machine language, all you have to do is type in like so. So this is the same program run in machine language. Done. We just ran through locations 8000 hex right to C something because we're into the disk extended BASIC. And in BASIC the program couldn't even finish. So we'll demonstrate it again. Anytime you need to call your subroutine, like so. So this is what we're going to do in our machine language. We're going to use three registers, the X, the Y, and the A to hold the data. The Y will contain the ROM location, X will contain the screen location. So we'll load from Y into A and we'll store it into X. And we'll keep doing that until we get to our end. Alright, so to start our editor assembler, start by the I command. It gives us an opening line. We'll say where we would like our program to start. Hex. Now we can start writing our program. So we'll start by loading into X our value of the ROM. Then here we're going to give a label so we can come back here. Now we're going to load into Y our screen memory location. Load into A. What do we want to load into A? We want to load into A our ROM. So that's in the X register. And we want it to auto increment. Oops. It's here. Now we want to store it into Y, and we also want to increment it to get the next location. Now we're going to compare Y to the end of the screen. Now we're going to branch if we haven't reached the end of the screen. So we know our screen locations are 10, 24, decimal to 15, 35. I put 34 by mistake. Now we want to do a loop. So where do we want to go? We don't want to go here because we'd reload at the beginning. We want to go here, which is unmarked. We'll just call that loop. When we're done that, we will compare to see if we've read all the ROMs yet. So we're going to compare X to that's the end of the ROM cycle. Now we're going to branch So we're going to compare x to this number. If it's lower than that, branch if lower than, we're going to go loop up to the page label. And really that's going to be it. We're going to return to basic and we're going to end this program. Now the only thing we have to do is we have to edit line 130 and we will insert a label. So here's our completed program. It's very small. We're going to start the program at 6000 hex. RAM location, we're going to load the ROM location into X, load the screen location into Y, then we'll load A, whatever's in this location of X, and then we'll store it in the screen location of Y. We'll check if we're at the end of screen. If not, we are going to branch to the loop. If we've done the whole screen location, we're going to compare it to the end of ROM. If we haven't passed the ROM yet, we're going to keep looping. So all we have to do is assemble this, like so. And now we have our machine code that we can use for our basic subroutines. So we'll go and type that in to our program and see how it runs. So now we go back to our basic program that we wrote. We're loading in our memory location where we want to poke our data. We're going to read data, check if we're at the end of the data. If not, we'll poke it in hexadecimal into that location. So this saves you time from writing poke 6000 whatever. So here's our data. Here's 8E means load X, location 8000 hex. Then we have our load Y with the screen location. So 0400 hex, we can see that over here. That's our 1024 decimal got turned into that. So now if we want to run it, we will type run 100. XCC, and we put it at 6000 hex. Okay, sorry about that, I'm not used to the camera. Okay, ampersand hex 6000. We're going to run this. And there we go. So, had you wanted to, you could have written this little program here on paper and just looked up the codes for load X is 8E. There's different kind of loads, of course. Loading X of a number is going to give you a different code than loading X with a pointer or memory location. So that you have to watch. And here, our branch if lower than, there's a symbol for that, and ED is the distance. If you take FF minus ED, you're going to see it counts back to where the loop is. So I hope this little instruction is going to encourage you to start writing machine language to make things speed up in your programs.